Hi, Ricardo. Are you there by any chance?
Hi, yes, I'm here. How you guys going?
Hi, Ricardo. I wasn't able to get your GitHub username. Are you able to email that to me real quick? Because I want to make sure you get added to the classroom.
Hold up.
When you need my email address, just let me know. Hey, Zandra. Hey, Rachel. How are y'all?
Hey, this is Sandra. Can you hear me?
Yep, yep.
Yep. Hey, doing well. Thanks.
Awesome.
Hey, do I need a new GitHub account?
No,
Or can
Rachel, I just gave you different access to our Pandas course for today, so you're set. You and Zandra are set.
Thank you.
Yep, I'm in.
Hey, Brett. How's it going?
It's going all right. Busy day. How are you guys doing?
Good, good. I think I did I meet you at the SPE CFD event? I think.
Yeah.
Excellent, excellent. Glad you're joining us today.
Which you're the one who knew Gilly, right?
Yes, yes. From running and other stuff. Yeah, Gilly's a good people.
Hey, it's Ricardo. Just sent you my GitHub username on chat here.
Cool. On chat.
Yeah, why don't you put up that first slide so folks can start going to classroom.datum.io if they haven't already.
That's a good idea. Okay. Ricardo, I got your GitHub. Okay. Are Amber and Peter on the line by any chance? This is a. Oh yeah, there's my Amber. Oh, I don't see either. Okay, I can message them. Ricardo, I went ahead and gave you access, so you should be set in a couple minutes here.
Brilliant.
This is Sandra. I see Amber is available, so she's probably just logging in.
Perfect. John, I'll give it a couple minutes. Just let people trickle in, and then I'll go ahead and get started.
No problem. Can you hear my audio okay?
Yep, you're good. Loud and clear.
I just heard from Amber internally within Chevron. She's just trying to figure out how to log into the various platforms. So I gave her some tips. She should be here soon.
Awesome. Yeah, we know the struggles on that side as well. So
Hey guys, I think I'm in the classroom, but it says your server is starting up. You will be redirected automatically when it's ready. Is that what I'm supposed to be seeing?
Yes.
yep.
Okay.
It usually only takes us a couple of seconds, but just give it a little bit longer.
And Rachel, did you use Chrome?
No, maybe I'll go do that.
Yeah, that one, I did the same problem because I clicked on the link and it automatically opens it up in another one, whichever one we have, Explorer, and that was a problem I had.
Okay, yeah, I had to disconnect from the VPN because it wasn't even letting me get in.
Try Chrome.
Yeah, why don't we start walking through some of the logistics? Because I think you're going to hit upon making sure we're on the right browser, where the right place to log on to the classroom is, et cetera, and just start walking through logistics. And then we can keep it up and answer questions that come up as new folks kind of join the class as well.
Cool. Yeah, John has quite a bit to cover today too, so we want to make sure we give him time. Hello, everyone. My name is Avi. I'm the product manager here at Datum. So on behalf of our team, I want to welcome all of you for Datum's Pandas for Excel Addicts workshop. So you're in excellent hands today with Dr. John Foster, who teaches a lot of our energy data science workshops and a multitude of Python and various Python packages. I don't want to steal from his thunder, but it's a great course. We're going to dive deep into Pandas here, and I just want to emphasize that with every skill, it takes some reps to become proficient. So be patient with it. John has some great examples today, and you will be writing active code, which is always fun as well as frustrating. As well as the final thing is we'll be recording these lectures, and I'll be posting them on the classroom after the workshop is over. So first thing to get to our Datum online classroom. Most of you have already done it, but please go to classroom.datum.io and please make sure you're on a Google Chrome browser, as many of us have found. So it'll work there. And then you'll click on sign in with GitHub, and you gave me your GitHub username, so I've given you access to that. So all you'll do is log in with your GitHub credentials. Just to not interrupt John as he's teaching, please make sure everyone is on mute during the class. If you do have questions, feel free to chime in, or if you want the font bigger, smaller, slower, faster, anything that you need, please feel free to interact with us. There are some features as well on Zoom that we can utilize to participate. There's the online hand raising feature, which is in the bottom middle of your screen, and then as well as we have a community, a little over 100 people, and we're all kind of data scientists in the energy field, and we like to sometimes discuss different things or ask questions. So that's on Slack. You can find us on Slack, and that Slack will be in your classroom, that link. And please communicate with me if you have any questions or concerns during the class. I'm here at your beck and call. My email address is avi@datum.io, or you can Slack me as well. I'll be on there during the workshop just to help troubleshoot anything. We don't want to keep interrupting John while he's teaching. And finally, of course, we love your feedback. So at the end, we will be asking for a quick brief survey just on John's class, kind of what you want to see moving forward, things of that nature. So without further ado, our CEO, Kunal Riker, for a couple words. You're on mute, Kunal.
course I am. Hey everyone, I see a lot of familiar faces in the audience. So for those who don't know me, my name is Kunal Riker. I'm the CEO here at Datum. Thought I would just spend the next couple of minutes just giving you a little bit about background on who Datum is for those of you who don't know or are new to our company. Datum, in essence, is an energy-focused data science education and training company. We basically do the hard work of translating the best of what data science and code has to offer into something useful for us as technical industry professionals. Our MO is really to develop these interdisciplinary training programs like the one that you're kind of sitting in now that marry the best of geoscience and petroleum engineering expertise with code and data-driven models, and to teach all of those who are interested how to do that for themselves. And so we carry out our vision kind of via a three-pronged approach. The first being the workshops and micro courses like the one you're sitting in now, where we introduce concepts. The second being our enterprise program that are a little bit longer in duration, but are centered around helping you make the most out of your data that you're using day in and day out. And the third is our online learning management system, where we allow you to kind of engage in your own self-paced learning journey. And so after hearing about what we do, and for those of you who already know, I'm sure you guys are curious to know a little bit more about our team as well. And so I would say you guys are pretty lucky because the team is fairly multidisciplinary, especially within our two co-founders. We cover petroleum engineering and geoanalytics fairly comprehensively. I won't steal too much of Dr. Foster's thunder, but he is our internal expert on all things software engineering, Python data ecosystem, geomechanics, and computational modeling. While Dr. Perch, who's not here today, but a lot of you are familiar with, is a longtime industry practitioner, the geostats guy, and the one who specializes in all things geology, statistical learning, and reservoir characterization. Avi, who you just heard from, spent a number of years in industry on the HSC risk engineering side, and is really good at bringing together the best of analytics and safety with one another. And then myself, I come from more of the investment side of the industry, where I've spent a lot of time focused on net asset evaluations, reserve modeling, and reservoir economics. And so whether you're interested in something geo-specifically, geomechanics specifically, HSC specific, or even just energy kind of finance specific, we can kind of build fairly multidisciplinary programs that help you apply data analytics and science to whatever you're most interested in. And so so you guys are sitting in a workshop today. It's a webinar focused on something a little bit more specific towards the application side. And so our goal with these webinars and micro courses that we're launching over the coming months is to take you closer to the implementation of putting data science and code into practice more effectively. And so for most of you, you guys have sat through our classes and kind of learned the basics of energy machine learning, of spatial data analytics, of the Python data ecosystem. But what we're trying to do now is take you to that next step and put stuff into practice more effectively. And so as you'll see shortly, as John goes through the course overview, the topic of discussion today is something that's near and dear to my heart, and I feel is fairly a common exercise within oil and gas, and that being just calculating well economics. This time though, with a little bit of a twist, and the twist being, how do we replace something that's traditionally done in Excel using free and powerful tools that afford us the ability to create kind of something that's a little bit more sustainable, more scalable, and something that saves us time, money, and leads to more efficient answers. And so going forward, we're going to be creating a lot more of this type of coursework that is exclusively focused on disrupting typical workflow pain points. And these pain points can range wildly from, you know, augmenting existing workflows like we're doing today, towards automating kind of the most mundane and rote tasks that you guys have to face day in and day out. And then also kind of ranging towards allowing for way deeper, more multivariate analyses as well. And so our goal is to help you and your team become more operationally efficient by better marrying the best of your subsurface expertise with code and analytics. And so while we may not be spending as much CapEx within the industry, we may not be drilling as much, we here at Datum want to make sure that your operations are kind of running at peak performance by helping you leverage analytics and code a little better than you were yesterday. And so should you have any suggestions for workflows that you're really interested in learning more about how you can implement code and analytics to help augment, feel free to let us know via the feedback form or just offline with any of our team. And so with that quick introduction, I'll pass it off to your lecturer for this morning, Dr. John Foster. So thank you.
Hey, hello, everyone. Thanks for joining. I think it's a great sized group, and hopefully we can have some interactivity. I know Avi mentioned, don't interrupt me, but I think with this smaller group, if you have something to say or have a question, it's fine to just speak out, as long as you will mute yourself after you say something. Sometimes the background noise can be a little distracting, but other than that, feel free to speak up. I have my chat window open as well, so hopefully I'll be monitoring that during the course. With that, let me go ahead and start my screen share. I guess, by the way, I really enjoy seeing people's faces. So if you want to turn your cameras on, if you have a camera and you'd like to turn it on, it's sometimes useful for me just to see some head nodding and other kind of interaction in these webinars. So if you do have a camera and you'd like to turn it on, I appreciate it. Hey, Alexandra, good to see you. All right, so I'm gonna go ahead and share my screen. So everyone should be looking at the landing page of our classroom. Let Avi know if you're not looking at what I'm looking at here. You won't see all of the files and that I have over here, but you should at least see this folder called Pandas for Excel Addicts, and we may have to dive into that later. If you'd like to hide this, so what we're looking at here is something called Jupyter Lab. We'll be using Jupyter Notebooks today. And again, just due to the focused aspect of this webinar, I won't go into a lot of details about Jupyter Project and Jupyter Notebook, but if you take our longer energy data science workshop, you would get more information about that. So what you're seeing here is a cloud-hosted Jupyter Lab session. And what you can do is, if you'd like to hide this file browser, if you just click over on the left top, the thing that looks like a folder, if you were to click that, and that toggles the file browser on the left side. So if you need it open, you can click it. Otherwise, it's sometimes less distracting to go ahead and minimize it. We've already had so what we're covering today is listed in the table of contents down here. We've already had the datum overview. I'll have just a little bit longer introduction of myself and I guess why I think I'm qualified to teach you guys this. Then we'll dive right in with Pandas. We'll talk about exactly the workflow we're going to tackle today, and then we'll go ahead and dive on in. So we'll spend probably 30 minutes lecturing, just an overview of Pandas, and then another 30 minutes to an hour actually writing some code to follow that up. So I'll go ahead and, if you want to see what the slides I'm going to be presenting from, they're available as Jupyter Notebooks by just clicking Introduction or later clicking Pandas if you wanted to go ahead and open those up. And in fact, what you'll see me presenting from will appear to look like slides, but they're nothing more than the restyled notebooks that you see here. And in fact, the notebooks have a lot more information in them because they're intended to be read like a document. So, a lot of the words that I will say during my presentation are written out here. And so that's available for you to see. So with that, let me just say a little bit more about myself. Today, this is me, John Foster. Dr. Perch is the other co-founder of Datum. He won't be teaching today, but if you were to take one of our longer courses, you would certainly be hearing from him any aspect of machine learning, anything like that. So a little bit more about me. Datum is my second job. My first job is as an associate professor in the Department of Petroleum Engineering and Hildebrand Department of Petroleum and Geosystems Engineering at the University of Texas at Austin. I also have appointments in aerospace engineering and engineering mechanics. It's another department at UT, and have another appointment in the Odin Institute for Computational Engineering and Sciences, which is the, if you're not familiar with that, it's really the center of the world for computational science and engineering. It's the number one computational mathematics program in the world. And my background is really in forward physics-based simulation. So before I came to academia, I worked at Sandia National Labs for 7 years, where I was essentially a code developer writing engineering physics codes that would exploit the world's largest computers, which the Department of Energy historically has always had. So I bring with me that background, and you know, typically that work back then was done in C++. I still am very proficient in C++, but as time goes on, I found myself using Python more and more. I've used it basically daily since 2011, so I think I have a pretty good handle on Python. I'm also proficient in several other languages, MATLAB, Julia, Mathematica, Fortran. So I've been coding a long time, and I have a pretty strong background in software engineering. So not just you know, kind of hacking code, but actually writing production quality software with unit testing in place and continuous integration. And it's some of these things are why we're going to prefer Python and Pandas over Excel in many cases, because the code quality will be much higher. And I'll point that out when I can. I have a GitHub page if you'd like to go look at that, where you can see a lot of the code that I've written for different various projects over the years. Also pretty active on Twitter. I record all of my lectures from the university, and they're available on YouTube. I don't have a link here, but you can find me there. Or if you just go to my Twitter page, there's several links to the videos, the more recent videos, that you can kind of find me on YouTube that way. Same goes for Dr. Perch. Again, well, we already mentioned he's the geostats guy, very present on Twitter. I think he posts daily, contributed a lot of workflows on GitHub, and is very active on YouTube, recording all of his lectures as well on data analytics, machine learning, other topics like that. So with that, if we were in person, I would basically want to go around the room and have you all introduce yourselves, your name, your company role, and your expectations for the class. But that can be a little bit unwieldy in this Zoom environment. So in lieu of that, I've prepared a couple of poll questions just to help me get a feel for who I'm teaching to. So I'll launch the first of those here. There's just some questions about your field of work and your programming experience and expectations for the course. So let me go ahead and do that now and give you a minute to answer those questions. So I appreciate all the answers. It looks like we have, I guess I can share the poll results. Looks like we have kind of a more or less equal split between petroleum engineering and geologists, geoscientists. I guess I'm curious about the others. Maybe you can write in the chat box the two that answered other, what other is, what you mean, what you're interested in that. I had a question, John, what is your Twitter ID? That's a good question. I think it's John T. Foster. Let me verify that.
Confirm, John, it is.
Yeah, John T. Foster. Okay, thank you. It's been a long time, I guess, since I logged in. I mean, not logged, I use it, but you know, I actually had to type in the login information. So what best describes your computer programming proficiency? Looks like there's various answers there, kind of equal across. Some used Excel, some used some VBA with Excel, a little bit of Python, and Python plus Pandas. So if you didn't know, of course, Pandas is a package that goes along with Python. So there's, in teaching this kind of very short webinar, that, you know, there's no way I could teach you all about Jupyter Notebooks and all about Python and all about Pandas in a couple of hours. So the focus today will be Pandas. We will, of course, be using some you know, pure Python, particularly in one example where I show how to kind of automate some of the workflow that we'll create within Pandas. So there's kind of this implicit understanding that you know a little bit about Python coming into this. If you don't, you can just follow along when we're writing code. And so, okay, mining engineering. Okay, yeah, I would count you as engineering other, but anyway. And the last looks like, you know, just learning how to convert some of the Excel spreadsheets into Python Pandas workflows. It's exactly what we're going to do today in the exercise. And so you'll have a good idea of how we do that. And hopefully along the way, I'll try to point out why I think you should do it, and particularly in terms of code quality and reproducibility. You know, we're not going to make anyone proficient in Python Pandas in 1 or 2 hours, but hopefully you get some ideas that you can take and learn more about. This webinar is really just advertisement for a longer course that we'll be launching very soon, which will be, you know, like a one-day class in person or virtually probably 2 half days. With the class will have the same name, and we'll go further into depth in a lot of the topics that we're going to cover today. So with that, I think everyone by now should be on classroom.datum.io, hopefully following along with me. And if you're not, you can contact Avi as mentioned at the beginning of the course. If you've taken our longer energy data science course, it's a 3-day course in person or spread out over 5 half days in virtually, but when we've offered it recently. If you've taken that course, the lecture slides that I'm about to present on Pandas will probably look familiar because they're very similar to what I teach in that class. However, don't get too bored and leave, because the workflow exercise that we'll be covering after the lecture will be quite different than what I cover in the energy data science course. So let's jump right in. Pandas is a package for data analysis. It's an add-on to Python, so we use it from Python. It's an external library that we have to import. It's not part of the standard Python library. And really what it's best for is kind of two-dimensional Excel-like data, right? So we often think about data in Excel as, you know, sort of having columns and rows, and where the columns would have labels, and in the lingo of machine learning, we would call those features or predictor features. So the columns would have labels, and the nice thing about Panda is we can actually refer to those columns by their names, the names that we give them, which is allows us for a lot more readable code, in my opinion, than using Excel, where the columns are labeled for you, you know, essentially alphabetically. And then the rows, which can be labeled with just a monotonically increasing integer like Excel has, or you can also label the rows with some other type of index. The most common sort of secondary type of index would be a timestamp. You know, so your row label could be a timestamp to when you have time series data versus just monotonically increasing numbers. And so Pandas is really good at these kind of two-dimensional data structures where you have, you know, columnar, and, you know, if you're here because you're looking for an escape from Excel, then you're looking, you know, this is exactly the type of data that Pandas is useful to work on. There is another package called Numpy, which is really useful for numerical computing, and it has actually n-dimensional data structures. So not just two-dimensional, not just rows and columns, but you could have, you know, third dimension, fourth, you can actually have n dimensions. you do not refer to the dimensions by labels in NumPy. It's really strictly for numerical computing. And in fact, Pandas is built on top. Some of the functionality of Pandas is built on top of NumPy. And we'll see that. We'll see how to extract NumPy arrays and other things. And in fact, in the workflow, we just, to do what we want to do, we can't avoid using a little bit of NumPy along the way as well. I just realized there's a typo in my title there. I will fix that. So whenever we import Pandas, if you're familiar with the Python world or you've seen NumPy at all, it's basically standard, use case to import NumPy as NP. And the same goes for Pandas. It's idiomatic, essentially. It's the canonical way to import things. You would import the Pandas package as PD. And the reason I mention this is because if you go to websites that like Stack Overflow, where a lot of people ask questions, coding questions, and request answers from the community, often you'll see that the answers, and when they're referring to Pandas commands, they'll just have the PD in front. And we'll see examples of the syntax coming up. But just know that when you see that, because often you won't see the import statement on Stack Overflow, you'll just see the PD, and just know that PD is referring to the Pandas package, and any commands associated with are part of Pandas. So it would be, I guess you could say just import Pandas without the short name, but to call it anything other than PD would really confuse people. So I would advise against doing that. So loading data. Pandas has some great functionality for reading in data. The most common way I would say that people are storing data and reading data into Pandas these days are with comma separated value files. So if we have a comma separated value file and we'd like to look at it, in this case, we have a file called 200 wells. It's called 200 wells because there are actually 200 rows, all of them corresponding to different information from well. And this is some petrophysical information about the well. So the XY coordinates of the well, that's, not petrophysical, but the facies, the porosity, permeability, acoustic impedance, or information about the samples that came from the well. So here, the head command automatically prints out the first 5 rows of a data frame. So I'm reading in this CSV file. I'm storing it as a variable df. That's short for data frame, because the data structure, the fundamental data structure of Pandas is this data frame, which again looks like kind of an Excel worksheet, right? It has columns, but in this case we get to decide what the column labels are, and it has rows that are labeled by an index. In this case, it's just the default labeling would be a monotonic set of increasing integers, but you could also have, again, timestamps or any other index that might be useful to you. So there's 2 commands here, right? The first one is reading in the data from the CSV file, storing it as a data frame, and the second command is just printing it, the first 5 rows, to the screen, okay? There are also commands, read_Excel, which would allow you to read an Excel workbook without having to convert it to a CSV. There's another command, read SQL, which would actually allow you to attach to a SQL database and issue a SQL query and pull the data into a data frame from there. Again, I mentioned that the kind of canonical way that a lot of people are storing small data. And when I say small, it's actually not that small. This read CSV and loading the data into data frames will work just fine for several million rows of data. Now, if you get into the hundreds of millions or tens of millions to hundreds of millions or billions of rows of data, then it's likely that you would need to do something else. But Pandas is perfectly capable of handling several million rows of data, no problem. So that's in and of itself an advantage. I'm sure we've all ran into the issue of trying to load, a million rows into Excel. It can cause a lot of problems if you can do it at all. Okay, so with that, we've read in some data with read CSV, and we've printed it to the screen. There are many, many built-in functions on data frames. And Python is an object-oriented programming language, which means that you have data, in this case, df, that stores our data in the data frame. And we have member functions of that class, data frame class, that can operate on that data. And so, the syntax for doing that is to take the object, which is df, and then the dot, so if you come from another object-oriented language, C++, Java, JavaScript, I mean, many, many other ones have adopted this type of syntax where you have your object, and then to operate on that object, you put the dot and then call a function. In this case, the function doesn't have any arguments. It's called described, and what it automatically does is compute some summary statistics of your data frame. So as I mentioned, this data frame has 200 samples. So if you look, the count of every column is identically 200. Then you have the mean, so the average of all of the data down the columns, the standard deviation, the min max, and the quartiles. So that's computed automatically for you on the data in the data frame by just simply calling describe on the data frame. So we can get parts of the data frame. So if we want to pull off only one column, we can refer to it by its name, right? In this case, if we wanted to only look at the porosity column, we could index into it with this square bracket syntax. And in fact, if you're only pulling off one label, you don't need the double brackets like I've indicated there. So you could actually, this would work the same way with a single bracket, but I just put the double brackets in there to indicate or to show that that's how you would use it to pull off multiple columns. So again, if you're only pulling off a single column, you don't need the double bracket. But if you are pulling off multiple columns, in this case, porosity and permeability, you need the double column. So really what this is the outer column indicates that you're indexing into the data frame, and the interior brackets are a list of what you want to index, right? And so in this case, porosity and permeability. And then in both cases, and in almost all of my examples here, because I'm presenting this as a slide, I don't want to present 200 rows of data. So in almost every case, you'll see that I just use the head command. And again, that's just to only print out the first 5 lines. So you can also select rows and columns. You would do that by using the loc function, right? So loc, that's short for locate. And in this case, the syntax is that the first set of indices that you put here refer to the rows, right? So in this case, I want to take rows 1 to 2, and I want to take the columns by their labels, porosity to permeability. This 1:2 is called a slice in Python. And for example, I could change that to 1,3. Oops, what happened? Passing list likes to load. Not sure why it works for 2, but not 3. Well, that's what I get for trying to execute live code in my notebook here. I'm not sure why. Perhaps I didn't execute the cell above it. It's causing some trouble there. But if you could just ignore the errors there for a moment, and we'll return back. So the other thing I was just going to point out was that we can use this slicing type syntax to take slices of the column labels. So if you were to go back to our data frame and look at, originally we have, porosity, permeability, and acoustic impedance. If we wanted to take all columns from porosity to acoustic impedance, that would include permeability. We can use this shorthand slicing notation. Apologies. Oops. Sorry. We can use this shorthand slicing notation. So the colon will take porosity to acoustic impedance, and that would include the permeability column as well there. We can also do index-based selection with ILO. So, you know, the I just stands for index, so index locator. In this case, it uses the Python style slicing syntax. And so in this case, there's no labels, right? We're just going to take the first and second rows and the third through the fifth columns. They're just labeled integer-wise from left to right across the column headings in the data frame. So in this case, the third and fourth columns are porosity and permeability. I mentioned Numpy earlier. Again, Numpy is kind of the fundamental numerical data structured package in Python. And if we want to get the underlying data in a Numpy array, that is, we want to get rid of the label and the index, then all we have to do is take the data frame and just put dot values on the end of it. That's going to return, in this case, a Numpy array of floating point numbers, as you see there, that then you could use in any kind of numerical Numpy calculation. So if you're not familiar with Numpy at all, it's a set of data structures and what we call broadcasted operations. What we mean by that is if you have an array X, so an array of data like what you would see here, and we were to say store it as a variable X, and we had another array Y, and we wanted to do the element-wise multiplication of X times Y. In Numpy, that's just simply X times Y. And that will automatically broadcast the multiplication operation across all of the entries in the two arrays, allow us in a very compact and efficient way to do element-wise operations on arrays of data. If you come from another programming language, then you know that you typically have to do that kind of thing in a for loop, and it's not necessary in Numpy. So again, if you want to get the underlying data as a Numpy array that is void of the label and index information that the data frame carries with it, just add values to the end of the data frame command. In this case, we're only taking the porosity column, but you could actually compute this for the entire data frame as well. Just take out the data as a big two-dimensional array. So there's many transformations that we can do to data frames. We can, for example, relabel the labels for the columns. In this case, we use the rename function for that, which takes an argument columns, and then we just basically give it a dictionary, a Python dictionary of the current name and what we want the new name to be. So this is the syntax here. The old name was faces underscore threshold underscore 0.3. And here we just want to call that faces. And we want to rename permeability to perm, and we want to rename acoustic impedance to AI. And this is just an example. Of course, it could be anything. And perhaps we prefer to use these short names in our code just so we don't have to type as much. The in place argument transforms the data frame in place, meaning it in place in memory. It doesn't make a copy. If we were to leave that off, the default is false. And so if we were to leave this off, what this function would return would be a new data frame with the names transformed, but the old data frame would still be there in memory unless we did something to explicitly delete it. Again, we're just printing off the first 5 rows with the head command. We could easily add new columns to a data frame. We use the same syntax. If you're familiar with Python dictionaries and the syntax there, we use the same type of syntax here to add new columns to a data frame. So in this case, we're going to add a new column. The label will be 0. And on the right-hand side is what we're going to add there. And in this case, it's just going to be a floating point array of zeros. So this will have the length of the data frame, so 200. It'll be just an array of 200 zeros, and we'll add them in. And if we print off the data frame, again, there you see this column with the zeros in it. Rachel asked a question 10 minutes ago. I'm just now looking at the chat that asked, are there any limitations on the number of columns? I do not believe there are. I know, I've worked with data that had more than 100 columns. So I don't believe there are any limitations on the number of columns, up to, of course, the memory requirements of the computer. I have to move my chat box more. I have a 34-inch monitor here, so I had the chat box slid away off to one side of the screen, and it wasn't in my direct view. Okay, we can likewise remove a column. We do that with the drop command. So we drop, and you can drop by label. In the case that you want to drop a column, you do have to specify the axis equal to 1. So the default is axis equal to 0, and that would refer to dropping a row. Right? So if you wanted to drop a row, you would just do it by the index name, which in this case are just integers. So if we wanted to say drop the first row, you would just say drop 0. And then you don't have to put in the axis argument, because the default is 0, and that would drop the first row. Again, we're using the in place here to do it in place, meaning in place in memory, not returning a copy. In almost all cases in this exercise, you'll see this in place true argument to the functions I produce. Just because I don't want, in this case, the data frame is not very large, but if you really had millions of rows and hundreds of columns, you wouldn't want to be making too many copies of that type of thing in memory. So it's just another example. In this case, I'm actually dropping a row by its index. So you see there are no additional arguments here. I'm dropping the row labeled 1. Remember, Python is 0-based indexing, so the first row is actually 0. In this case, I'm dropping the second row, which has a label of 1, and you see that it's missing now from the data frame. We can do things like you do in Excel, of course, like sort values. And so in this case, we're going to sort based on the column porosity. We're going to have ascending false, so that that'll force it to be the largest number first and going down. In this case, instead of just using the default argument to head, which is to print off the first 5 rows, I've given it an argument n equals 13 to print off the first 13 rows. Again, that's just to show you more data here. And what you also notice over here is that the indices are jumbled up, right? Because they've been sorted, but they will retain their original label. And, this might be confusing or frustrating when you have just monotonically increasing set of integers that refer to the rows. However, if these were, say, timestamps or something like that, well, of course, you'd want the timestamp means something, right? It's more than just an integer label. And so you would want that timestamp to travel with the data so that you know how it corresponds, right? And so in this case, you'll notice the indices are all jumbled up over here. We can reset the indices if we wish, unjumble them. So in this case, you'll notice that the data frame is still sorted based on porosity, but we call this reset index command, again, in place, which will re-index the numbers in a monotonically increasing way there. The drop equals true, if you recall, we dropped there was no row 1 originally. And so the drop equals true allows us to ignore that fact and just label them in a monotonically increasing number from beginning to end, okay? We could do some so-called feature engineering, right? So feature engineering is a term for machine learning. It's basically where we're going to, use our knowledge of physics or some other understanding of the problem and use the existing features to create some more meaningful feature that we can use in a machine learning model. In this case, our new features aren't very interesting in any way. we're just converting the fractional porosity to a percentage porosity and adding a new column to the data frame. And we're computing the ratio of permeability and porosity and adding a new column to the data frame, as you see here. We can add conditional categories, and in this case, the way we're going to do that is we're going to use this so-called Numpy where command, and I'll talk about the syntax for that. But basically, what we're going to do is we're going to add a new column to the data frame called porosity type that is either a value high or low. So it's just a string. It's going to be high or low. And so the Numpy where command, what it does is the first statement is a conditional statement. So basically what this is saying is where this is true, where the porosity is greater than 0.12, where that is true, I want to put a label high, and where it's false, I want to put a label low. The nice thing about, again, when I run this data frame porosity greater than 0.12, what that produces is, and we'll see this when we go to the workflow later, but what that produces is an array of trues and falses, right? So it's not just a single true and false value because there's 200 rows, right? So there's one true or false value corresponding to every row in the data frame. And so where those rows are true, we attach the label high. Where it's false, we attach the label low. And then again, and then in this case, what I'm actually doing is also using some Boolean indexing to show you where some of the high and low values are, right? So of course we've sorted our data frame. All of the high values are the first values, right? So I have to go down into the data frame some way to look for the low values, and they don't appear until the 165th. You know, the first value of porosity below 0.12 is the 165th row. Okay, and so the syntax here again, what you see inside the brackets produces a Boolean array. So where porosity type is equal to high. Again, this is going to be an array of trues and falses, each corresponding to a row in the data frame. So where it's high, then I can use that to index back into the data frame. Again, this putting this array of trues and falses back in as an index. We index into data frames with the square brackets. So I put that back into the data frame as an index, and that allows me to return only the values where the porosity type is high. And in this case, I'm only printing off the first three. So it's just the first three rows of the data frame because they were already sorted. If we do the same thing for low, again, now we have to go to the 165th row to find a value where the porosity is less than 0.12. And I'm just printing off the first three of those. But it would actually go on to the 200th one, right? So from 165 all the way to 200 would be porosity low, again, because we already sorted the data frame. We can also do some truncation. We'll actually do this later in our workflow example. In this case, we're going to create a new feature called Perm Cutoff. And here we're just going to say, okay, well, wherever the porosity is greater than 0.12, we're just going to, Perm Cutoff is going to take the current value of permeability. But wherever it's less than 0.2, we're going to set the permeability to a very small number, 0.001. That's millidarcy. So again, then I just use that to print off the first three columns of the data frame, and you'll see out here the permeability, the Perm Cutoff is the permeability, right? They're identical, 174.654 and 174.654. However, where the porosity is less than 0.2, if I go and look for those in the data frame by using this Boolean indexing again, now we see that the Perm Cutoff and the actual permeability are different, right? So we have 0.266 was the actual permeability, and we've, in this Perm Cutoff column, made it 0.001. So.
Hey, real quick, John.
Sure.
Yeah, what's the significance of your double equal signs there?
Oh, this is a test. So a single equal sign is an assignment, right? So in this case, we're taking what's on the right-hand side and assigning it to the left-hand side.
Okay.
The double equals is a test, is a conditional test. So I'm basically saying where the values of Perm cutoff are identically equal to 0.0001. And that will produce, again, a Boolean array, trues and falses. True where this is true, false otherwise. Okay?
Thanks.
Clear? Okay, so this is where you start to get into things that you're used to doing in Excel, particularly with equations, right? So in Excel, you have the ability in the bar at the top to put an equal sign and write an equation. Of course, the annoying part is that you have to refer to the columns and the rows via, their kind of arbitrary indexing, right? Whatever the default values are, the column or A or whatever like that. Whereas here we can actually do things in a more mathematical way. And in fact, in this example, I'm actually using even Unicode characters in my equation, right? So what this is, I have a function that's going to take a value of porosity. I call it phi, okay? And also a value of m. If you're familiar with the Cosini-Kármán relationship, so the Cosini-Kármán relationship is a model that relates porosity to permeability. And m is essentially the proportional coefficient that is fit to, in a least square sense, that is fit to correct that model, to make it the more precise for any value of a more precise prediction for any value of porosity, predicting permeability. So in this case, this is the Cosini-Kármán model. It's, if you recall that, if you're familiar with it, it's porosity cubed over 1 minus porosity squared. And then we just multiply that by a parameter m. So what we're doing here is we're saying we have a more complicated function in that we're not just returning the Cosini-Kármán relationship, but we're returning it only if the porosity is greater than 0.2. Otherwise, we're returning this small value of permeability, right? So this is kind of like what we did earlier with cutoff, but we've made a Python function, right? So again, if you're familiar with Python, we make function definitions with def. And the nice thing about this over, say, an equation in Excel in particular, is that this is easily testable. In software engineering, we want to write small functions that each have a single responsibility, right? In this case, the responsibility of this function is to return the permeability, given a value of porosity and a value of this factor, m. The default value is 5. And so we have a function that has a single responsibility. It's easily testable, right? We can all pull out our calculator and see what this function should return for a value of porosity at 0.013, right? Or 0.13, right? We could do that easily, or even on a piece of paper. And then, later what we would want to do in writing high quality software is we would want to actually automatically test this function. So we would use some type of test suite, some testing tools, possibly continuous integration that would allow those tests to run automatically. And again, a code test is just an assertion, right? So if I put in a value of porosity, I'm going to assert that it produces a known value of permeability. And we could write a test that would traverse both of the channels of this if statement, if this is true and otherwise. And we could, essentially test the functionality of this such that it's always true. And so this is a big advantage over Excel in terms of readability, in terms of the ability to test your formulas and whatnot. So then what we'd like to do is we want to apply this function to a column of the data frame. And that's what we do in this second code cell here. So in this guy, we're going to create a new column of the data frame called Cosini-Kármán. and it's going to be populated with values that are applying this function over the porosity column. So you notice that there's the apply automatically takes the first argument, which is phi, and replaces that with df porosity, right? So the porosity column of the data frame, this function will be applied over that. So these values of porosity will be stuck into this equation, and then what's returned is the value of permeability. Now in this case, I'm printing off the default, all 200 rows of the data frame. The default for Pandas to print suppresses the interior rows. So you see the first 5 and the last 5. And we can see this new column, Cosini Carmen, which has, for the larger values, has the model applied to it. And for the smaller values, it just passed it through 0.01. The nice thing about this is this function could be arbitrarily complex, right? This could be 2,000 lines of code, and you could apply it to a data frame with just this one line, right? I would like to see any of you write a 2,000 line function in Excel. It's virtually impossible to do correctly and test well. There's some built-in features for handling missing data, right? So often our data is missing or not clean, and we have to make some decisions about what to do with it. So in this case, what we're going to do, first of all, is stick in a missing value, right? So we'll say df, we'll use this at command, which is similar to loc, except it only is for accessing one value. So loc, you can take a slice, right? You can take a slice of rows and columns, but at is only a single value. So at row 1, in the column porosity, I want to replace whatever's there with none. And you'll see that that automatically gets transformed into a nan, not a number. Because Pandas has the built, this column of porosity are floating point numbers, right? They're all decimal place numbers. And so this none automatically gets replaced with a floating point nan in this column of data. So there's some built-in functions for dealing with missing data in a data frame. One of them is called isNull. So that's a testing function. It returns a Boolean array, trues and falses. So basically what the inside of this code here returns an array of trues and falses. True where it's missing, false otherwise, right? And so if I use that to index back into the original data frame, then you can see I'm getting that row back where we intentionally stuck the nan. So that's one way to find missing values. If you had a million rows in your data frame and you were looking for ones with missing values, this would be a nice way to test. It would pull out only the ones where there's missing data. And in this case, only missing in the column porosity, but you could call isNull on multiple columns or in the entire data frame.
Do you have an example of when you want to fill in the nulls with nan? Like I've had some spreadsheets where they're just blank cells and I want to fill it in with nulls.
I don't. Let us work through the workflow later, and if there's time at the end, that should be something that's fairly easy to fix. Yeah, I mean, if they're blank cells, it really depends on what the data type of the column is. When you read in an Excel workbook into Pandas, or when you read in a CSV into Pandas, it actually gives you some commands at that time that you read it in as to what to do with that missing data. Again, please remind me when we get to the workflow in a minute, and I'll show you some more details about that read CSV file, so you might be able to handle the missing data right at read time And so your data frame wouldn't have any missing data from the very beginning. And then we'll also try to do an example where we replace it with something. So there's also a command to drop missing rows just in one shot. So the drop NA. So if we just call that on the data frame, it will just drop that whole row. Right? Not always something you want to do. You know, often this exercise of replacing the missing data with some value is called data imputation in machine learning or data analysis. And there's tools to do that. You know, you can have automatically replace it with the average of the row, the median, other things like that. Or you can interpolate. There's lots of ways to handle that. But if you just want to get rid of those rows altogether, then you can just call drop NA. And a lot of times when you're debugging a workflow or something, it's often just easiest to just, you know, if you had 200 rows and all of them were populated but one, at least in your code development, you might want to just drop that row, get your code working, and then come back later and try to figure out how to deal with that missing data. So in our example here, so far, we read in the data from a CSV file. And I would say that's the most common use case in Pandas, is that you're reading the data in from elsewhere. But there is also the ability to create a new data frame from scratch. So in this case, I'm using a couple of Numpy commands here, basically just creating some random values that are near 0.2 for porosity, and then I'm applying the Cutoff model to create a bunch of random values for permeability that are associated with that porosity. Then we create a Python dictionary. So again, if you're familiar with the Python dictionary syntax, it's keyword value, keyword value. In this case, the values, porosity and permeability, are variables storing these NumPy arrays. So there's 100 data points in each of these. And so then to take this Python dictionary and turn it into a data frame, all we have to do is pass that into this PD. Remember, import pandas as PD. We just have to replace import pandas as PD. Then we call PD.dataframe and read in or supply the argument, the Python dictionary, and that creates a new data frame. In this case, I call it data frame new, and we can do all the things that we did to the other data frames. So we can sort the values and, you know, in this case, print out the first 5 after being sorted. So that's why the indices are all jumbled like so. You can merge data frames. So if you have 2 data frames and you wanted to create one from the 2, and so in this case, I'm going back to our original data frame. I'm using the iloc command to take the first 3 rows and all columns past the first one. First, all columns beyond the one index column. That is, if you remember, our data frame had X and Y in it. So in this case, I'm just pulling off the petrophysical data. I'm calling that data frame 1. Same thing here, but I'm pulling off rows instead of rows 0 to 3. I'm pulling off rows 10 to 13. They're here, and then I can concatenate those 2 data frames into one new one. So again, we use the PD concat, pass it a list of data frames we want to concat. The axis equals 0 means we want to concatenate along rows. So if we wanted to concatenate along columns, we would use axis equal to 1. In that case, the indices would, if you were concatenating along columns, the indices would need to match, right? So it would only concatenate from one data frame the 0 indice with the 0 indice from another data frame. Also, you notice in this concatenated data frame along the rows that the indices are left unchanged from their original values. So you could re-index if you like. Pandas has some nice so Sebastian has a question. What happens if you try to concatenate 2 data frames with identical IDs. Again, if the index were identical, then it would only really be meaningful to concatenate across columns, being like add new features to the data frame. If you're concatenating along rows, then it's going to basically, you need to have common column labels. Anything that's out of whack will just return missing values, right? So if you tried to concatenate two data frames that had a different number of rows, say one had 50 and one had 100, then just like in Excel, you're just going to have blank data below the 50th column in the first one, but it would be one data frame. You just have blank or missing data below the entries of the original one. So hopefully that answers your question.
Yes, thanks.
So Pandas has some really nice built-in plotting in a sense, nice in the sense that you can get to plots quickly, which is often what we want to do. In data analysis or data analytics is often just clever visualizations, right? And a lot of it is. And so to be able to quickly inspect our data is really nice in that if I just call, if you recall, our data frame new only had the columns of porosity and permeability. And so if we just call plot on it, well, it tries to plot it, but it doesn't know what it's doing there is actually it's plotting porosity and permeability as two separate lines against their indices, right? So just, is a question from Brett. What about combining data frames by matching multiple variables? Like well-named formation. Yeah, that's equivalent to like a join in SQL. You can do that for sure. I don't think I have an example of that. That is something we do in our injury data science class in the Pandas exercise. In fact, we do that very thing. So it is possible. There's a command called merge that works on data frames. There's another one called group by that allows you to group by certain variables and then possibly merge. So the two commands that you would use to do that would be one of either, depending on specifically what you're doing, would be merge or group by. Again, I don't have an example today of that, but in our longer courses, we do have examples for that type of thing. So returning to plotting here, again, the issue with this is that our index is just a monotonically increasing set of integers. It's basically meaningless. And so if we try to plot, the default call to plot plots the data frame versus their indices. And this works really nice when indices are timestamps, because then you get a time series plot without any additional stuff going on. But in the event that you get something like this, it's easy to fix. We can do one of two things. One, we can set the index. So instead of the index being just a bunch of numbers, 0 to 200, we could set the index to be porosity and then call plot on that. And then we get something that's meaningful, right? So here we have permeability as a function of porosity. Again, this is according to that Cosini-Kármán relationship. We could also just specify the X and Y axes for our plot explicitly. So for example, in this case, just to demonstrate a little more functionality, in addition to plot, I'm calling scatter as well. And in this case, just giving it the label X equals porosity and Y equals permeability. And that will also produce a plot. In this case, because I told it to be a scatter plot, it produces a scatter plot. So this is really convenient for just quickly looking at relationships in our data frames and other things without a lot of extra code.
Hey, John.
Yep.
It's just such a widely used data set for geoscientists. Can you make the permeability a log scale? Show us how that's done real quick.
Yeah, you definitely can. Let's I'm trying to, I think there's, so you know, there's a limited number of built-in plotting tools. I was just about to say, all of these plotting tools are built on top of a plotting library called Matplotlib. The Matplotlib is kind of the de facto standard plotting library in Python, although there are other plotting libraries that are really good too. So under the hood, you know, behind the scenes, when you call this scatter plot, it's just issuing a bunch of Matplotlib commands. You know, when I give my full lecture on Matplotlib in our energy data science course, I always start off by saying that any two-dimensional visualization you've ever seen can be recreated with Matplotlib, and it's pretty true. So you can absolutely you can absolutely do anything under the hood with Matplotlib. You can make a log plot or something like that. In terms of using the pandas plot commands, I actually don't know off the top of my head how to make it a log scale, although somebody just put some information there. And so it looks like if I wanted to say log x equal to true, there you go. It's that simple. So thank you, Sebastian. Yeah, I would have had to do the same thing. If you look in the chat box where Sebastian put, there are tons of options to plot. And you can, if you notice this star keywords in the end, you can basically pass any Matplotlib plotting functionality through this. And so you really have full control over these plots to do anything you want to do. But this is a very, you know, concise syntax for doing something quickly. Thank you, Sebastian. I would have had to look that up myself, because I mean, if you look, there's so many options, it's almost impossible for anyone to memorize all of them. So then finally, it's real easy to write a data frame to a file. Again, since we read from a CSV, our example here will also write to a CSV. So in this case, we're just taking our data frame that we did all those transformations to, sorting them and other things, and writing it out to a CSV file, and ignoring the index, because the index was just these integers that are kind of meaningless. So then if we were to use the Unix head command to actually look at what the data frame looks like on the file system, it's just, you know, this is the comma separated value file that was written out. There's other formats you can write to. I don't actually believe, while you can read from an Excel sheet, I don't actually believe that you can write to it from Pandas, but there are other, you know, if you have like random access database like HDF5 and other things like that for hierarchical data, you can write to those kinds of things as well. You know, any kind of open format you can write out, just very simple Pandas command like this. So that's kind of an overview. By no means is this every function that in Python, but that kind of gives you the common things you would do. And we'll learn some other stuff as we begin to work through this workflow. And so with that, let's return to Jupyter Lab and our table of contents. And here, if you click on this type curve monthly production, you'll open a Jupyter notebook, and it'll be mostly empty with just kind of one code cell that has our price deck information. So what we're going to do here is, let me briefly stop sharing that and show you. What we're going to do here is recreate a common workflow that a production engineer would have. And that is taking some type curve information, so that this data up here in the upper left-hand corner of our Excel spreadsheet is kind of the price deck that is replicated in that first cell of the Jupyter notebook. Then we have basically monthly oil and gas predictions from a type curve. So if you're a geologist, geophysicist, you don't know what a type curve is, it's basically you take the actual production history and you fit a function to it to predict into the future how the well is going to deplete, right? What the production will look like into the future. And then it's a common workflow for production engineers to do some pricing information on that future prediction to understand if and when the well is economic. And so this is a very common workflow, and this is what we're going to reproduce in and hopefully even extend in our Pandas example here. Kunal, are you there? Do you want to add anything to that?
Yeah, no, I mean, John, I think you covered it pretty well. Idea being, we all, I think at some point or another, want to calculate the economics for a single well based off of a type curve. And what we found is it's pretty easy to do and straightforward to do in Excel. Although when you're tracking hundreds of wells and trying to create reports on a weekly basis, Excel is not necessarily the best tool to do it. So by putting in some common inputs like an oil price deck, a gas price deck, an NGL price deck, along with some, various kind of OpEx and CapEx assumptions, how can we calculate the NPVs, the IRRs, the payout periods fairly sustainably and scalably in another tool that's not Excel or not Aries for that matter? And so I think, John, that's exactly what we're trying to recreate, just using Pandas and a few other functions as well going forward for this exercise.
Yep. So with that, real quickly, I'm going to end the Pandas lecture with a little quiz, just to see where everybody's level of understanding is. Fairly simple. Some questions there. Please answer them. I'll quickly go over the results, and then we'll start our workflow here. Okay, it looks like most everyone has completed. In the interest of time, I'm going to go ahead and end the poll. I'll share the results. Everyone did great. I mean, obviously, it was pretty simple. Please import Pandas as PD. Read arrow is not a function. Arrow is Apache Arrow is a project for big data analysis. There is a PyArrow package that you can access Arrow data structures with, and they're very similar to Pandas data frames, but it's not part of Pandas. There is no read arrow, but there is a read SQL, read Excel, and read CSV. The head function prints out the first 5 rows of the data frame. To have a function manipulate a column of data, we would use the apply function to do that. To remove a row from the data frame, we could use drop, and a new data frame can easily be constructed from a Python dictionary. So everyone seemed to understand that. Let's move right into the workflow here. What you're looking at is a Jupyter notebook. If you're not familiar with it, I'll give you a 2-minute rundown of what we can do here. Jupyter notebooks are nice for mixing explanatory text and equations. Explanatory text, equations, and actual executable code, and the outputs of that code, plots, whatever. The way you execute a cell, a code cell in Jupyter Notebook, is to type Shift Enter. So the default will execute that cell and open a new cell below it. The default for a new cell is a code cell, but it can be changed to something called a markdown cell. Up here at the top, you see where my cursor is, it says code. If we change that to markdown, we could write some explanatory So Markdown is a lightweight markup language that produces rich text. So the markup here, like for example, the word highlighted, I've surrounded in asterisks, and that will, when I execute the cell, will result in something that's highlighted. Likewise, the double asterisk results in something that is bold. So if I execute that cell, you can see that we get the rich text formatting there. If I go back and double click on that cell to enter the edit mode again, I can add equations. The equations follow something called LaTeX syntax. So if you're not familiar with that, but so we could have something like, we just talked about the Cosini-Kármán relationship. You have to know a little bit of the syntax to be able to use it properly, but it is very nice. For creating really nice equations, right? So there we get a really nicely formatted equation, and this is intermingled with our code, right? So now we're going to go on and write code from here, and this is really nice, you know, for basically writing out with mathematical language what our code is doing, particularly when we want to share the code with other people. Okay, so we have this set of inputs stored up here, which the reason I store them in a Python dictionary, hopefully will be made obvious as we work through this workflow. You have, you're looking at what I'm looking at, and I'm encouraging you to follow along with me. Unfortunately, in the interest of time, I mean, I'll try to go slow enough that everyone can, hopefully follow. But in the interest of time, I won't be able to pause long enough to ensure that everyone is up to speed at all times. So I'll have to kind of move through this quickly to get done in the next 40 minutes or so. But I will say that the final version or working version of what we're going to create here is available. If you go, remember, to the file browser, if you've minimized it, you can open it by clicking on the folder icon up there in the upper left. Go to the Pandas for Excel Addicts. If you were to open that, and then there's a folder inside there called Final, and that has this notebook. The notebook file extension is always IPyNB. It has a complete version of that notebook. So please don't look at it now. You'll be jumping ahead, cheating. But if you can't follow along with what I'm doing here, it is available for you to look at later. Okay, so again, I'm going to minimize the file browser, and let's get started. So the first thing we're going to do is import pandas as PD. And again, we can execute a cell by typing Shift-Enter. You don't have to basically execute every line of code individually. You can put multiple lines of code in a code box. And so we'll go ahead just to demonstrate that. We'll go ahead and call the read CSV file, call read CSV. And this is the file we want to read in is a type curve. It's stored in a folder called data. Again, if you wanted to see that, it's there in the Pandas for Excel Addicts. There's a folder called data, and you'll see there's a bunch of type curve information in there. The one we'll look at right now is just type curve 1. So I got a request to zoom in a little bit. Let's see if I can do that. Is that helpful? I guess that was Avi. Yeah, okay. So the file we're going to read is in the folder data, and it's called typecurve1.csv. And if we look at that data frame, we can do that by just, you can suppress the output of any code with any code with a semicolon. So then either on a new line or directly on the line below it, if we just type data frame df, that will show us a preview of the data frame. So in this case, we have just 2 columns, oil and gas, and the index are these monotonically increasing numbers, but in this case, they actually refer to months. So each of these are months. This is the predicted production by month as we go into the future. And so because they're actually month, we're going to give the index a name. So I'll show you how to do that here. So we're just going to say data frame index rename, and we'll just call it month. And we want to do that in place. So we'll use that in place equal to true, and then we'll print out the result. And so now we just have a label for our index. It's called month. Okay. And that'll have.
John, can I ask?
Sure.
Can I ask you a quick question? I failed to do the first one, which was the import pandas as PD. Yep. Mine didn't highlight green, and I'm wondering. I typed exactly what you did. Is there something I need to do?
Yeah, likely you typed it into a cell that was markdown. So if you go there, does it where my cursor is? Does it say code or does it say markdown?
I see something that says raw.
Okay, click on it and change it to code.
Ah.
Now does it get?
There we go. Okay.
Yeah. So,
I did. Now it's excellent.
Yeah.
Another really simple question. Do these CSV or Excel files have to be loaded up into Jupyter Lab? Or can you read to your desktop or something?
We'll actually see an example later where we're going to take this. I had misunderstood your question. They can actually be anywhere that you can access via the internet. So this could actually be an HTTPS address. So in our case, it couldn't be on your desktop unless you had a locally running version of Jupyter Lab, which you can get by just installing Anaconda, the Anaconda Python distribution. So that'll give you a locally running version of Jupyter Lab, and then it could be on your desktop and you can load it. Yeah, in our case, all of this is hosted in the cloud so that everyone has access, right? So there's our data frame as it looks. And one of the advantages of labeling the index was that now if I call remember our data frame plot command, I automatically get, I mean, I know it's a simple thing, but I automatically get, because again, the default is to plot the data in the data frame against the index. And because I labeled my index, now I actually have a label on my plot as well. So I have oil and gas there.
So John, this is Andrea again. Sorry, I'm slow to the party. So I did what I thought was the same context. I have an error, and at the bottom of it, it says name error, name true is not defined. What did I do?
Name true. So on what line of code are you?
On line, your line 7, the in place equals true, I think is maybe where I went wrong.
Yeah.
Okay. Huh, okay, keep going, that's okay.
Yeah. Unfortunately, just in the interest of time, I won't be able to debug,
No, it's not a problem.
Everyone's code, in our longer courses, that is something I do. We have the ability to share screens and all of that. So anyway, I'm gonna have to move on. But yeah, the advantage of labeling the index is that you automatically get a label here. Now this is still not a very good plot because oil and gas have different units. And I guess I didn't mention that in our data here, oil is in units of barrels and gas is in units of MCF. And so we do have, so what I'm going to do next is I'm going to demonstrate, even though we haven't talked about Matplotlib in detail, I'm going to demonstrate using a little bit more complex Matplotlib commands to create a more, a better visually pleasing plot. So I'm going to do that quickly. I'm going to type import matplotlib.pyplot as PLT. Again, Matplotlib is something we cover in detail in our energy data science course. And I'm going to explicitly instantiate a plot with the subplots command. And then I'm going to create a second axis from the first by calling this axis 1 twin X rather, which means they'll share, the two axes will share the x-axis. And then I'll set the Y label of axis 1 to be oil in barrels. And I'll set the color of that to be blue. I'm going to do the same thing for axis 2. I'm going to change this to be gas in MCF, and I'll set the color of that to be green. And then I can go ahead and pass these axes I've created into my Pandas plot command. So here I'm going to plot, I'm calling off the oil column, calling plot, passing in axis 1 as the axis, setting the color of that line to blue. And I'll do the same thing for gas. This time passing in axis 2 and the color to green. If I do this, now I have a much better plot, at least in my opinion, in that, so now they have the correct units. I have two axes, oil, gas. The blue color corresponds to the blue line, which helps to give you some visual aesthetic there. That's just an example of how to use Matplotlib along with Pandas to produce a nicer looking plot. And we could do anything in addition to that, okay? So let's start to look at some things you would do in Excel. Like, for example, let's compute the ultimate recovery. So we're going to say gas ultimate recovery is equal to the sum of the gas column. We do that just by calling sum on that column. And again, if you wanted to see what the actual value is, you could see there. So the sum, the total there is 588,900 MCF. That's the predicted ultimate recovery from our type curve. So we'll suppress the output and just create another one for gas because we'll need it later. And not that it matters that much, but there was a typo there. Ultimate. And I'm just going to change gas to oil. So now I've computed the sum of those two. With that, I can add a new column to my data frame that shows the monthly percentage EUR. So we'll do it for gas first. By taking the gas column and dividing by the gas ultimate recovery. So Ricardo made a comment about case sensitivity, and yeah, Python is a case sensitive language, so the case does matter, uppercase or lowercase. So we can, so basically we're taking every month's oil and gas prediction, the monthly oil and gas prediction, dividing it by the total, and that gives us a monthly estimate. Oh, I see, I did a couple of typos there. Now if we look at our data frame, we have two new columns, each with the percentage recovery. Oh, since I labeled it percent, we should multiply by 100. Right? So now we have percentages. We added 2 new columns there. Now we're going to get into some of the revenue calculations. So what I'm going to do, just like we did before, I'm going to create a function. Like I'm going to call it compute oil revenue. And this function is going to take 2 inputs. It's going to take the data frame object and the inputs, where the inputs is this dictionary of pricing information that I provided at the beginning. So this function is then going to return the oil revenue. And just what I'm going to do is I'm going to take the part of the dictionary that refers to oil, right? So if you notice this, this is like a nested dictionary. So there's oil and it has a price and a differential. I'm going to call that OG price, right? Just assigning it to a variable. That gives me access to that nested dictionary in fewer commands. And so then what I'm going to do is just say OG price. So that's the price of oil plus the differential times the net revenue interest right? So our net revenue interest in this example is 75%. And that is going to be times DF, right? So whatever comes in as the input will be multiplied there. And so there's a couple things I prefer about this equation over Excel, and mostly it has to do with readability, right? Of course, the same arguments as before apply in that, you know, I can easily create tests to test the accuracy of this function, just given some inputs. You know, I could whip my calculator out and quickly verify that this is producing the right output, and then I could write tests and implement that, you know, automated system, okay? So I'm going to go ahead and execute that cell to define that function, compute oil revenue, and then I'm going to add a new data frame column called oil revenue, and I'm going to apply that function to it. Right? So compute oil revenue, and in this case, I have some additional arguments. Those are the inputs. And we want to apply it down the column so the axis is equal to 1. Remember, the default would be axis equal to 0, and that would be across the rows. So if we apply this function and then look at the data frame, oh, I made a mistake. I kind of switched my naming there. So OG inputs, OG price should be OG inputs. Oh. I forgot to specify that I want to apply this to just the oil column. Oh, I see. That should be here. There we go. Sorry about mistakes there, live coding. But yeah, so here's my formula, and I can just apply this function and to the data frame, and that will create a new column called oil revenue. Right? So this is my revenue for oil. Now, and again, if you're following along, I apologize. I have to do this in the interest of time. And if you're trying to code along, you probably won't be able to keep up with what I'm about to do, because I'm going to just copy from the complete notebook the other functions I need. So they're more or less the same style of function, right? And so it's just, I'm computing the gas revenue, the natural gas liquid revenue, computing the taxes, and computing the operating expenses. And the formula should be, because again, the way I named the inputs, they should be quite readable. You can just look at these and see exactly what they are. And so then what I want to do is apply those functions to create several new columns in my data frame. So for gas revenue, NGL revenue, taxes, and operating expenses. So now if we look at what our data frame looks like, we have something like this. So now what we can do is compute our cash flow. So the cash flow is just going to be the sum across the rows, of all of our revenue, taxes, and OPEX, right? So basically, I'm going to add the oil revenue, gas revenue, and NGL revenue and subtract the taxes and operating expenses. To do that, what I can do is use my data frame loc. The colon means take all rows, and the columns I want to take, I'm going to take from oil revenue to OPEX using that slicing notation, right? And I want to sum and now if we look at our data frame, we have our cash flows. So that's out here. So what I want to do next is I'm going to zero out any negative cash flow. So I can do that. There's a couple of ways to do this, but one way I can do it is I can use this loc command again and say that any rows where the cash flow is negative, specifying the column as cash flow, then I want to set that equal to 0.0. And if we look at our data frame now, you see that those negative cash flows are now zeroed out. So after that, we can compute a cumulative cash flow. By taking the cash flow column, computing the cumulative sum of it, and then we're going to subtract from that our capital expenditure, right? So that's the initial investment. And on our price deck, we called that CapEx. So now if we look at the data frame, we have our cumulative cash flow out there.
Hey, John, you have a chat question?
Sure. The axis equal to 1 specifies whether it should sum along the rows or the columns.
Okay, perfect. Thanks.
So now we have a cumulative cash flow. We can add another column that tells us if we're economic or not. So as long as our cash flow is positive, we have an economic well. So we're just going to set that equal to, remember this returns a Boolean array. We'll actually get to see that now. You just see out there, you know, it's true and positive, true and false, right? So as long as you have a positive cash flow, we have an economic well. Now, yep.
And John, I'm sorry, and John, that tells you exactly when the shut-in period is too. So you have kind of a tracking place as to here's the ideal shut-in point as well, right?
Yeah, exactly. Whenever that switches to false is when you'd want to shut in the well. Or do something else, some type of EUR, enhanced oil recovery. Probably well before that, but nevertheless. Anyway, so that's essentially all we need in our data frame at this point. But let's add some styling to it. So, you know, because a lot of times styling can help our visualization of what's going on. So let's add some styling to it. And in this case, what I'm going to do is, and then I'm going to copy over. What I'm doing here is I'm creating a dictionary, and the entries of the dictionary, I'll show you, right? So it has the columns of the data frame as they look up there, right? So oil revenue, gas revenue, NGL revenue, taxes, OPEX, cash flow, and cumulative cash flow. These are all the money columns. So I want to use an accounting format like we do in Excel. And what this function specifies, so this is a function over here. And what that specifies is just, these are special string formatting syntax that specify how this stuff is going to look when it's formatted. And so what I'm going to do is I'm just going to take that data frame and apply this formatting dictionary to the style. And so immediately you see that now I have all of those money columns are using an accounting format. So I have a $ out front, I have parentheses for negative numbers. But we can do more. We can actually, Pandas allows us to actually put a bar chart in the columns. And so what we're going to do, I'm going to surround this guy with a parenthesis so you can see what I'm doing. In Python, you can have multi-line commands as long as they're surrounded by a parenthesis. So in the first line, I format the dictionary. In the second line, in the first line, I format using that format dictionary. And in the second line, I'm going to apply a bar chart where the color is going to be red for negative values and green for positive values, where the minimum value in the bar chart will be the cumulative cash flow. The maximum value will be the maximum of the cumulative cash flow. The subset that I want to apply this formatting to will be the cumulative cash flow column. And then we'll just align the bars in the center of the frame. And so as long as this entire thing is surrounded by a parenthesis, so the outer parenthesis here, this allows me to have a multi-line. This is a one-line command. I've just split it into 2 lines. And I can do that as long as the whole thing is surrounded in parentheses. So with that, if we execute that cell, now we get something like this, which basically, in addition to the numbers being there, it also puts a bar chart that shows us exactly, how negative we are, how we're increasing, when we become cumulative cash flow positive. This is your payback for that well, and then you just continue on down. So that's just a nice styling there, and then we'll just add one little bit more styling here. We can highlight the maximum and the minimum of a column. So we're going to highlight that, again, coming inside that last parentheses, hitting carriage return, and then I'm going to paste the maximum and minimum highlight applied to the economic column. And I'm going to color it with light green or red. So again, what you should see here is this kind of thing, right? So the well is economic, it's green, and eventually you start to see some reds, which means that the well is not economic. The inflow cash is not exceeding the operating expenses and taxes for that well. So that's just adding some styling to the data frame. I don't like this really long scrolling that I have to do right here for the moment. So what I'm going to do is I'm going to right click on the output in JupyterLab, and I'm going to say enable scrolling for outputs. And then that will basically put this really long data frame into a smaller box that I can scroll through, so it's not taking up my whole screen. Of course, we can make plots with the values that we computed, right? So for example, if you wanted to plot the cumulative cash flow, it's just as simple as that. Right? I won't take any effort to make it any nicer. Now we're going to create a summary table from the table that we have here. And so what we have to do this, we have to compute we want to compute in the summary, we want to compute the internal rate of return and the NPV, net present value for the well. And unfortunately, there are some financial functions built into Numpy, but they don't allow you all the freedom. The default is to compute the NPV on a yearly basis. And since we have monthly data, we actually need to write the function ourselves. So we'll do that real quickly here. First, we'll import numpy as NP, import scipy optimize. This is going to allow us to find an optimal value here in a second, a curve fitting routine. And so we're going to define a function x NPV. This is just like, or will be similar to the x NPV function in Excel, where we take a rate, a data frame, and the inputs. And then from that, we're going to take the cash flows. We're going to go ahead and insert into our cash flow array. So we're going to take the cash flow column from the data frame, convert it to a NumPy array. In the first entry, we're going to stick our capital expenses, our CapEx. Right? Those are our initial investment. I think it's 3.6 million for this well. So that will give us our cash flows. Again, this is just the initial capital expenditures followed by everything that was in the cash flow column over here. So the first one will be minus 3.6 million, and the second one will be 6.45. So that gives us our cash flows. And I'm just going to call this years, where we're going to take our data frame index, convert it to NumPy, add a 1 to it, because remember we added a row to the cash flows. That is the capital expenditures. So we need to add a row to our years column. And so we're just going to add 1 to what's there and then stick a 0 in the first one. So at year 0, we have only our capital expenditure. And then that whole thing we're going to divide by 12 because we want this to be in years. We want our formula to be in years, but our data is in months. So we're going to divide it by 12, and then we can just return the NPV formula, which is the sum of the cash flows divided by 1 plus the rate to the power of time, which in our case is years. And that's what we're going to return from this function. Then we'll define our XIRR function to take a data frame and inputs. And it's just going to call the function from scipy optimize, which is a curve fitting function, fsolve, where fsolve takes the xNPV function as an input. We'll put an initial guess of half, or 50%. So with those two functions, then we can create a new data frame that will be our summary table. I'll start creating it here with the IRR and MPV10. Again, that is the IRR here. Is a strange number, but it probably because this price deck is not actually associated with this well, so we get something that's greater than 100 there. So it's not realistic, but nevertheless, it's not going to matter. So, so there we have our IRR and our MPV10, and we're going to add to that. Again, in the interest of time, I'm just going to copy and paste a few cells, and I'll explain what they are. We're going to have add a column for return on investment. So that the return on investment is just you know, the how long it takes before we make our money back, or capital expenditure. And in addition to that, we'll go ahead and compute at what month that will happen. Or I'm sorry, we'll compute the year, the fraction of the year at which that'll happen. And then with all of that, we can stick this dictionary into a data frame using, you know, so we created this dictionary called summary. We're going to stick that into a data frame. We'll round off to 2 digits, and then we'll style it a little bit. And so then we get this kind of summary table here. So again, kind of a crazy IRR, but nevertheless, the other data is correct. Right? So in this case, we'd have a return on investment 2.81 years and payout at 0.83. So what we can do now, Jupyter Notebooks are really good at this kind of exploratory work or developing workflows kind of one line at a time, right? However, what we can do now is we can take this Jupyter Notebook that we created, and what we'll do is we'll actually, if you go over here and you go to File, Export Notebook As, so we'll File, Export Notebook As, and we'll export it as an executable script. That will actually download a script to your computer wherever you'd like. And what I'm actually going to do is then upload that script back into Jupyter Lab by dragging and dropping it into, and then we'll go ahead and look at what this is. So this is an executable Python script where all of the non-code has been commented out. So everything that was in our Jupyter Notebook is there, but what was non-code, like the equations, the text we wrote at the beginning, this has all been commented out. Okay. Now, what I intended to do was to show you from here how we can make this, you know, what started as a Jupyter Notebook into an executable script that we can run over multiple wells. But since we're nearing the end of our kind of 2-hour allowance here, I'll just we'll just skip to the final product. So if you go to Pandas, the folder Pandas for Excel Addicts, and you were to open up the final folder and open up typecurve monthly final.py, you'll see the Python file there where it's everything that was in the Jupyter Notebook. I've just reorganized. So all the function definitions, all the import statements are at the top, followed by all the function definitions. And all of the data frame specific stuff we put into a function called create full data frame. So I have a function that's called create full data frame. What I mean by full data frame is this big one that has all of this data in it. Okay. So that everything that was required to generate that data frame, I put into this function called create full data frame. It takes a file name, that is the CSV file where the data are, inputs from an input deck, and this return data frame false is just something I put in there. But anyway, in addition to that, I have another function that creates the summary data frame. So in order to create the summary data frame, we first have to create the full data frame. So I'm just calling create full data frame from within, create summary data frame, and returning. So this is a type curve monthly final is a Python module that we can actually import. So for example, if I go down here, I could say, I should be able to say now, import data type, import final type curve monthly final. And if I execute that, then I can have access to the functions that are in there. So for example, type curve monthly final has a function inside it called create full data frame. And that takes a file name, which is data type curve 1.csv, and a list of inputs, which we have at the top of the screen. I don't know why I wrote data there. It should be final. And produces that data frame. So now I can essentially get rid of all of the other code in this notebook. I only need the inputs and the final data frame, because everything else has been moved to that Python script. So let me just quickly do that. Again, you have access to the final version of this notebook. But so now, with nothing but this, I can just create the full data frame. Likewise, I can create the summary data frame. And there it is. Additionally, what I can do is now I've moved my inputs to a separate file. I just call it inputs.yaml. This is my price deck information. YAML is a standard markup language. You can see the syntax highlighting and stuff. The idea was that I could put my price deck information in this, and then what I can actually do with just a little bit of additional code is I can run this script. It's going to read in the inputs, provide a little bit of styling. It's going to find all of the type curves. So in this data folder, there's multiple type curves. It's going to find all of them, find all the CSV files, and then create this summary data frame and output that to an HTML file. So again, this is a little bit of kind of non-Pandas specific. This is pure Python stuff that I'm doing here. But then, just to demonstrate this, I can open a console, which will allow me to run I'm sorry, let me close that, move into the final folder, open a console, and then I can run this script. Run type curve monthly. So that's running, and it's completed already. And if we return to the home folder, you'll see a new file there. You can see that it was created seconds ago. And this has, it's called summary.html. And what this did was basically it ran those calculations over the 10 wells. And the key sort of thing here is that it doesn't matter that it's 10 or 10,000. Yeah, it would take a little bit longer to run if it was 10,000. But you can have sort of one script that you can then run over all of your wells, provided that they had these kind of CSV formatting, and produce this summary table. And because, you know, in this case, I chose to print it out at HTML. Well, because it's HTML, you have the full power of HTML. So you can style this however you want it. You could have it automatically deploy to a website where, you know, so you're no longer sending, you know, this gets towards automated reporting, right? You're no longer having to send attachments of Excel files to your boss or something like that. You could completely automate the process in a, you know, a very, you know, that would run very quickly. You could have this auto deploy to a website, so it would be available every day. You could have it automatically run every morning. You could have it pull from a REST API to get you know, accurate pricing data if you wish. You know, the current value of WTI, for example, anything like that. You essentially have the full power of the coding capability of Python at your fingertips to do this kind of thing. So the last thing I just want to show you is kind of extending beyond. I mean, I think this already hopefully gives you some ideas about how you could extend this in ways that would, you know, exceed the capabilities of Excel. But there is one last thing I just want to show you quickly, and that is there's some really nice interactive functionality built into Jupyter Notebooks. So I can say import IPy widgets. Let's say, I'm going to say from IPy widgets, import, interact, and widgets, or widget.
John, I think you misspelled IPy widgets. I think there's a G in there.
Yep. There you go. Thank you. And so then what I can do is I can create a new function that I'm going to call interactive type curve. And it's going to take oil price and what was the other one? Oh, operating expenses, oil, OPEX, and I'll give it some default values. So we'll set the default value to wishful thinking 50. And the operating expenses to 2.64, which is what they were in our default. So this is a function. And in this function, all I'm going to do is take my inputs up here and copy them in there. And instead of having the 50 hard coded, I'm just going to replace it with oil price. Same with OPEX. I'll replace the oil operating expenses right here. So basically whatever this function, whatever I put in for oil price and oil OPEX in this function is going to get replaced in inputs. And then from there, I can just return my final type curve monthly, create summary data frame. In this case, I want to create the full data frame. And so if we execute that cell to initialize the function, I can then call the function like we're used to. So I'll just put in 50 and 2.64, and we'll get back identically the data frame we had earlier. Nothing new there. But what I can do now is I can go back up here where I have the function definition, and I can wrap this in something called interact, which allows me to then say I have oil price that I want to allow it to vary from 20 to 65 in increments of 50 cents. And likewise for the operating expenses, I'll allow that to vary from $2 to $3 in increments of 0.1 And then I'm just going to put this extra command that is continuous update equals false. That just, now look what I have. I have my data frame, and I have two slider bars that were created, which allow, so I can change these slider bars. And when I stop changing them, if I were to have continuous update equal to true, it would do it in real time. In this case, if I move the slider bar, once I stop, everything is recomputed and the values change. So I don't know if you noticed that, but our payout changed from like month 10 to month 21 when oil is 36.50. Likewise, I can mess around with the operating expenses. So this allows me like a very quick visual tool to say, you know, okay, well, what would happen if our operating expenses increase? How would that affect our, you know, pricing going forward? And of course, we could have it output the summary table as well with these kind of interactive, if that was more important to you than seeing all the details. Now, the one sort of thing that a lot of people say was, the one thing I like about Excel, I mean, I don't think anyone really loves coding formulas in Excel the way you have to be forced to through that. But the one thing a lot of people really like about Excel is just the ability to sort of, you know, you type in an input and everything updates. Well, you can actually use the same functionality here. In this case, I'm gonna, again, I'll copy over some code and replace the default for a floating point value is a slider bar. But if we wanted to explicitly have like a text box, then I can replace it with this bounded float text, which actually allows me to bound the float. So in other words, if you put in a value of 10 or something, then it's not allowed. So now I have an actual, you know, text box that I can input values. And you see, if I try to go below the minimum value, it automatically changes it. You know, it tells me the value must be greater than 20 because I've specified that. So this allows you to create, you know, easily create little user interfaces right within these Jupyter notebooks. If that's what you're kind of used to using Excel for, is to see how things change. But you know, you have a lot more power with these kind of slider bars. There's many widgets that you can implement too. You could add one that would allow you. You could basically build your own sort of type curve pricing analysis tool, relatively easy, allowing you to select different files that you want to upload, have it automatically compute the pricing, whatever. So with that, I mean, we've already been at it about 2 hours and 15 minutes. So I think that I'll stop now. I would like to launch one final poll with one question, and that is, how likely are you going to use Pandas in the future for some of your Excel workflows now that you see the power of some of what it can do?
There's only one right answer for this.
Ah. Well, if everyone said one, then obviously I didn't do a good job demonstrating the features. So that will conclude our webinar, at least what I have to say. I will hang out in case there's any questions. Kunal, do you want to, or Avi, you guys want to say something about filling out the?
Yeah, absolutely. I can just give a couple quick closing remarks as people are finalizing this poll. So thanks everyone for joining. Really appreciate you guys spending the last couple of hours with us learning. As a quick wrap up and an update, we'll be posting this video to the learning management system. So exactly where you're kind of viewing all of these notebooks and the class materials, we'll be posting a YouTube link so that you can re-watch a lot of this stuff at your leisure. Also, you'll be able to find the final workbook, the Jupyter notebook, for you to kind of create on your own as well. So I know, Rachel, you had a question about, doing this locally. If you have a local Anaconda instance and want to use your own local CSVs, you should be able to do that. If you could do us a huge favor and fill out the short feedback form at the top of your learning management system, that would really be helpful as well. Any thoughts you guys have on the course and suggestions for the future on other things you'd like to learn would be much appreciated. We'll be sending out a reminder for when the recording is up as well. So when you do that, feel free to fill out the feedback form now or then. And it kind of helps us kind of gauge what you guys are interested in learning next, and new courses and pain points that you're interested in solving, in the near future. So obviously we went through a lot very quickly today on kind of implementing Pandas and kind of just showing a detailed example of that. This webinar was really meant to give you a taste as to see kind of what's possible within Pandas, and specifically by just taking an Excel workbook and sheet and recreating it using just Pandas and a few other libraries as well. And so obviously we hope that this kind of spurs your imagination as to other ways you can start to think about replacing some of your Excel-based workflows where appropriate, right? You want to use the right tool for the right job. And so where you're interested in scaling your processes, exploring Pandas is always a good option. And so as John mentioned, we'll be launching a longer duration course for Pandas for Excel Addicts specifically, where we'll be actually spending a lot more time going through each of those blocks of code in depth, so that you can ask and we can review all questions that you have specifically on Python syntax, on the libraries, on other different plotting features that you can use to create visualizations and analytics around. And so, again, no, it's kind of drinking like a fire hose while we kind of review this like at a high level, but we'll be offering more courses like this in the future. And so any feedback and thoughts you have on other things you'd like to learn, we'd really appreciate. And so with that, I know we spent a lot of time going through a lot of this material. We'll conclude with that, and really appreciate everyone's time and looking forward to seeing you guys soon. So thank you for joining us.
Thanks, everybody. And again, I'll hang out for a few more minutes if someone has a question, technical question about this.
What package is Interact a part of, John? Is it its own standalone thing, or is it part of some package?
IPy widgets.
It's IPy widgets is a package.
It should be installed in the Anaconda distribution by default.
Okay.
Do they have a widget equivalent for pivot tables? Like an Excel pivot table?
I'm sorry, a widget equivalent?
Yeah, so you know how you can do kind of you get an interactive view of different summations that you can expand and collapse.
So I guess I'm not familiar with the interactive view in Excel, but briefly I'll just say yes, because because you have the full power of Python, you should be able to create any kind of interactivity you want. And there are pivot table like functionality in Pandas, built into Pandas. So it should be fairly straightforward to do something like that.
Thanks.
And the cool part about that, Brett, is it really depends on how much effort you want to spend up front too. So as John mentioned, we spent a lot of time today going and developing, one large function and workflow that you could then scale pretty easily to a bunch of different files. So if there's kind of a specific workflow that you want to interact and kind of show different variations of pivot table, you can create that in Pandas initially and then just apply that over and over again to whatever CSV files you want to read in and whatever data you want to read in as well, and then have some of that functionality. I'm a native Excel user myself, and I'm always amazed at how far you can go within, Python and the Python data science ecosystem to have a look and feel very similar to Excel in terms of, like John showed, like being able to put in, manual inputs for, various price inputs, et cetera, and then kind of grow from there and have it in a more scalable fashion than, running a bunch of data tables within Excel and needing to walk away. So we're going to be developing more on that as well in the future, and any thoughts you have or questions you have are welcome.
Yeah, those are all kind of expanding workflows. So on the geoscience side, sometimes we've got issues with like I want to run percentiles on a data set that I've aggregated in a pivot table so that I can run that through as probabilistic inputs for prospective resource assessments. Sorry, I got a 3-year-old in the background. So
Okay.
yeah, so those are the kind of things, or like pivot tables in Excel are solely focused on numeric summations. You can't have any strings in your data set. So like expanding on that same pivot functionality, but using string data would be really helpful in some cases.
Yeah, I'll have to think of an interesting example for that.
Cool. Any other questions we can help answer? If you do have questions that come up as you kind of marinate on some of this information as well, feel free to shoot them our way via feedback or via email. Would love to get back to you on it and get your thoughts on anything else you'd like to learn. For us, you know, sky's really the limit, and examples are easy to come by if there are specifics that you're most interested in learning about. So it's really about pointing the cannon for us. We try and start with kind of some of the basic pain points that everyone kind of at one point has had to come across, whether it be economics or, you know, other various analytics kind of problems and questions. So the more input we get from you guys, the more we can kind of develop to your liking. So we'd love your feedback and appreciate all of your time.
Okay, Kunal, perhaps we should just end the webinar.
Yep. Thanks, John. Thanks everyone for joining. Hope to see you guys soon. Take care.
Bye.
Thank you.